Okay, so where we left off, we were just filling in our numbers in number 6. So 40 newtons minus 5 kilograms times 0.7. So that's going to be 3.5, 0.7. And then over 5 kilograms times 9.81 meters per second squared. And you end up getting 0.7441 as your coefficient. Okay, so that's B. All right, that's 6B. Number 7, you were driving a 2,500 kilogram car at a constant speed of 14 meters per second. You slam on your brakes, the wheels lock, so there's no forward force. So if we draw our forces in here, we have FG going up, FG may be going down, Fn going up, friction acting backward, it's what's stopping you, no forward force. If you're trying to stop, maybe don't put your foot on the gas, okay? So if there's nothing forward here. From this we can find our acceleration. So again we would use Vf squared equals Vi squared plus 2a delta d. And so A would be equal to Vf squared minus Vi squared over 2 delta d. Vf goes to 0, you're stopping, so it'll be negative 14 meters per second, and that gets squared, over 2 times 25 meters. 14 squared is 196 divided by 50. And so it's going to be very close to 4, 3.92, and it's going to be negative meters per second squared. Okay, so that's our acceleration. If we did the sum of the forces in the y direction, it would go to 0. It would be Fn, again, minus Fg equals 0. And so we would get Fn equals Fg equals mg. You have your m, so you could find this value. I'm not going to do it because it's going to be messy. M is big, times 9.81. Instead, I'm going to go to sum of the forces in the x direction, equal to max. And in the x direction, the only force is friction, acting backward, equal to max. And we know friction is mu Fn, equal to max. And we know Fn is mg, equal to max. And look what happens to the m. So why would I multiply it out to then just divide by it? Why not just cancel it, and then who cares what the m is, and who cares that it would give you a big yucky number, because it's gone. I assume you're trying to solve for mu. You are. So divide both sides by the negative g. Mu is equal to ax over negative g. Luckily, the a is also negative, so 3.92 meters per second squared. And the negative will cancel each other out. And mu is going to be equal to 3.9959. Oops, paper's moving. And maybe there's a 0 in front there. 0.39959. Okay, done. All right, all those were easy, I hope, I think. Now we get into the slightly more complicated ones, which you did do in grade 11. Forces acting at an angle. Whenever it says the force is pulling, it means it's upward at an angle. And I would highly suggest you draw it upward coming out of the box, just like we draw all of the other forces coming out of the box. Some of you will draw it going into the box from the bottom, and that's just going to screw up your components, okay? The angle is with the horizontal. This will be Fx. This will be Fy. So the first step would be to find your Fx and your Fy. Fx is the adjacent side, so it's going to be cosine. So it'll be F cos theta. And your Fy will be the opposite side, so it's going to be F sine theta. If you want, you could find the values. You could do 300 newtons cos of 36.87. And you could do 300 newtons sine of 36.87. 36.87 cos 0.8. So this is like 240 newtons or something very close to it. And this is 180 newtons or something very close to it. Okay, once you do that though, everything else is the same as what we've done. we're going to do sum of the forces, and we're going to start in the y direction. And this question is one of the reasons why I've been doing all the y directions up there. Still going to go to 0, but this time going up will be Fn, Fy, and going down will be Fg. So we have a third y force. Positives and negatives, we call up positive, the first two are positive, Fg is negative. Always in the y direction, you're looking for an expression for Fn. So take the other two to the other side, where it becomes Fg minus Fy. And so Fn, Fg is mg. And this we set up here was F sine theta. If you actually filled your numbers in, then it would be 60 kilograms, 9.81 meters per second squared, minus 300 newtons sine of 36.87. So 60 kilograms, 9.81, what is that, 588.6, I think? So 588.6 newtons minus, and we had already found this, it was 180. And so you get 408.6. And now you go to sum of the forces in the x direction. Sum of the forces in the x direction, we take a look at our picture. There's Fx and there's friction. So Fx minus friction is equal to max. Fx we found up here, oh, actually we're looking for A. So Fx is F cos theta, and FFR is mu Fn. And if we're looking for A, we would divide both sides by M. And now we can fill our values in. F cos theta we already found, it's 240 newtons. Mu they gave us, it was 0.3. Paper's moving. 0.3. The Fn we found over here, 480.6, or excuse me, 408.6. And then we are going to divide that by our M, which was 60 kilograms. Okay, and then all that's left is type the numbers in and get your A. It's getting very hard to write down here because my paper's running out. So when I multiply by 0.3, that's 225, and then 240 divided by 60, and I should get, I don't know, do you get 1.957? I hope so. I didn't, but let's try that again. 240 minus bracket 0.3 times 408.6, close bracket, divided by 60. Yeah, 1.957. 1.957 meters per second squared. Okay, so there are the first 8. Now, the next guys are also pushing and pulling at an angle. Whenever it says pushing, like in number 9, it's going to be downward, okay? So if this is your box, it's going to be going down like this, and the angle is always between the horizontal and the force, okay? So this will be your Fx, this will be your Fy, and that's your F, okay? So pushing will be downward at an angle, pulling will be upward at an angle. You should now be able to do all the way up to number 13, please. So those are the ones I'd like you to work on today. All right, have a good one. Thanks.